So position, velocity, accelerations, we've talked about this some, just kind of making it more detailed and write it out more information. So position, this is like I threw a ball up in the air. So, this is like the height of Mr. Brust right here. Goes up, comes to the top, comes back down, hits the ground. So that's position. And that equation is so that's the position function. So the derivative of that, and we talked about this a little, I think, like every time you take the derivative, you lose a power. So like a parabola turns into a line and it's squared into 1 power. So that's a squared. So the derivative will be negative 9.8 t plus 18. So that's gravity. So the plus 18 will be here. Can you tell me where? It's a negative slope, right? So it's going to go down somehow like that. Think for a second. Don't say it out loud, but can you tell me where the x-intercept is? Tell me. Can you think in your head where the x-intercept is? So the only thing I know is true here. Like I'm trying to graph the slope of this, right? This is going to represent the slope of this. There's one spot on this graph where I know exactly what the slope is. Everywhere else I'm estimating. What's the one spot where I know exactly what it is? At the peak, right? So at x equals 2, what's the slope? 0. So at x equals 2, my velocity needs to be 0. So that's going to be where that crosses. And then just realize, like, you're looking at graphs differently now. I think up until this point, you've always had position. I don't know exactly what you're going to do in physics, but velocity graph, you just have to read it totally different. If the velocity is positive, meaning above the axis, a positive velocity means you're going either up or to the right, depending on if it's like side to side or up and down. So this particle is going up until the 2-second mark, which I think makes sense here. It goes up until the 2-second mark. So then I've got a negative velocity, so it's up below the axis. That's when it starts going back down because the negative velocity is down. And then if I take the derivative of this, I get negative 9.8, and that's gravity, right? That's the meters per second squared of gravity. And that's a constant force, so it's just a horizontal line here. So just talk about that Wiggles thing for a second. This does not work with like sine and cosine. Those just go forever and that doesn't do any good. But if I have like x to the third, that's an x to the third graph, right? So the derivative of x to the third is x squared. Have we done this? Have we talked about Wiggles? Yeah. Let me back up a second. Yeah, that's what's funny. Everyone's gonna know what I mean, but I'm not gonna explain it. Not those Wiggles. Not I'm not going to define the word wiggles, but I'm going to ask you how many wiggles that has. And I'm guessing almost everyone will say the same thing. How many wiggles? 2. 2, 3. So like there's a wiggle, there's a wiggle. That's an x cubed graph, right?
Oh, that's pretty cool.
Excellent. What did I do?
It has 2 wiggles, so
It's the
x.
derivative.
Yeah.
Derivative of a lot of wiggles.
Gotcha. Okay.
Yes.
So x squared would look like this, which is how many wiggles? 1 wiggle, so that's 1 wiggle. And x, so if I take the derivative of that, it's going to look like, hold on. Velocity is, so it would look like this. I don't do that, so you can tell that they're different.
It's not like.
But if you look at that as a line, how many wiggles does a line have? 0 wiggles, and then we could even get like weirder. Like, what has less wiggles than a diagonal line? A horizontal line? That was a little bit of a stretch. But like, let's say this was y equals 3x. Your derivative would be y equals 3, so then it would turn into just a horizontal line. 2 wiggles, 1 wiggle. That's kind of 0 wiggles, and that's like 0, 0, 0.
Extra zero. Extra zero.
Extra 0. Yeah. All right, so go back to like the. So we saw that here. It's gone. Like that had 1 wiggle, velocity at 0, and then that had like extra 0, right? I wrote down the functions. Okay, velocity less than 0. So that very often means velocity graph. Like it could be algebraically or graphically. Velocity graph below x-axis means the particle is moving backwards or like down or left. It kind of depends on the way the problem is phrased. If you're moving up and down, side to side, forward, backwards, whatever. But left is back. I'm not going to write it again, but this would be the velocity graph. Above the x-axis, that means we're moving forward. Or up, or right. And then velocity equals 0 means the particle is stopped. Like when you throw that thing up in the air, it comes back down, it is stopped. Average velocity would be the position at B minus the position at A divided by B minus A, which is just the slope of a position graph. Between 2 points. Let's speed. Speed is the absolute value of velocity. Right? That's what you're talking about. So speed always has to be positive. Velocity has a direction attached to it, positive, negative, forward, backwards. Speed is just speed. So just like a real quick thing, if I had a velocity graph that looked like this, that's B of t. The speed's absolute value, which things still can't be negative. So it would be like this part's not negative, so that would be the exact same. Speed graph would take the part that's below the axis and just like bounce it up. So it just makes everything positive. So it's already positive state, and it's negative. Okay. Questions yet? Yeah. Alright, speeding up or slowing down. If the velocity acceleration have the same sign, the particle is speeding up. If different signs, the particle is slowing down. So, this is like some particle, they know the velocity acceleration at these times. And it's just, if they're the same, speeding up. If they're different, it's slowing down. So this has like a positive velocity, so we're moving forward. But we're decelerating. So we're going forward, but we're going forward slower. So that's slowing down. That would be moving forward slow. And then at t equals 1, it's the reverse. Harder to wrap your head around a little bit, but this is like you're going backwards, but you're being accelerated forward. So like I'm running backwards, but there's like this rope around me that as I'm running backwards, it's like slowing me down and pulling me this. So this is also slowing down. But it's the opposite, so it's going backwards slow. And if they're both positive, we are speeding up. Can you tell me like moving forward or backwards, faster and slower? Faster and slower? This is moving forward faster, right? acceleration, so we're moving forward faster. And then this is also speeding up, but it's in the other direction. So you're going in the negative direction, and you're going to go faster in the negative direction. You're going negative and you're accelerating negative. So I'm going this way and I'm going faster and faster now. So this is moving backwards, faster. They don't really usually ask you those things, but I think it helps you understand. Question on that? Okay. Let's get into some problems here. Thank you. Displacement is the change in distance. I don't know why they don't do this here. No, I should say change in position. Distance, I don't know why they're like these are the point is to compare these two things. I don't know why that one's not here. Distance is total amount of travel. So here's my house. Here's the school. I drive there, it's 20 miles. I drive back, it's 20 miles. What's my displacement? Zero. Because I live exactly where I started. What's my distance traveled? This forward. So you add up those two. So you can find that a lot. Alright. Thank you, Max, for making me talk about it. So displacement in the first 2 minutes. They're giving me the position. I would need to know like where it was at the start, and then where it was 2 minutes later. I know where it was at the start, 2 minutes later, then I can subtract those to figure out the displacement of the particle. So I'm going to find x of 0. 0 cubed minus 4 times 0 squared plus 3. So 3, I think most of you probably could just look at that and be like, yeah, and then if I plug in 2, -5. I didn't find the displacement yet. I just kind of set up. So if the particle moved forward or backwards during that time, backwards, because at the beginning, you can look at it like a number line. At the beginning, I was here. At the end, I was here. So I must have gone backwards. And how much did I go backwards? 8. So it's -8. It's backwards. -8 centimeters. So you would do the ending position minus the beginning position. I think of it that way. -5 minus 3 would be -8. Average velocity during the first 2 minutes. Well, that's going to be the position. It's just the slope between those two spots. So the position at 2 minus the position at 0 over 2 minus 0. Let's say that would be minus FA or B minus A or Y2 minus Y1 or X2 minus X1. And that's the same thing, right? That's -8. That's what I just did up there. Divided by 2. So that's, I don't even need to reduce it because I might screw that up. That's -4, but nobody makes stupid mistakes. What is the label on that? We were in centimeters. We took the derivative, so now we're in centimeters per whatever, per minute. That's what they give the right idea. Centimeters per minute. Alright, velocity when t equals 4. I'm at position. To get the velocity, I take the derivative. So velocity is 3t t. Plug in 4 to that. Whatever that is. So that'd be 16. Also velocity, so that's centimeters per minute. Alright, acceleration when t equals 4, so now we gotta take the derivative again. So the derivative of velocity. So 6t. 6t minus 8. And then if you plug in 4, so 6 times 4 minus 8. That would also be 60 centimeters. That's acceleration, so it's squared. Thank you. Per minute squared. Speeding up or slowing down? Speeding up, because they're both the same sign. And would this be moving forward faster or backwards faster? They didn't ask that, but I am. Are we moving forward or backwards? Is it forward? Okay, why? I'm going to ask you why you do that. Why? Anybody else? Forward or backwards? I'm not moving out of freaking thoughts. Forward or backwards? Really, for forward or backwards, all I need to know is what the velocity is. If this is positive, we're moving forward. If this is negative, we're moving backwards. I think you're probably thinking about it too. It's like kind of straightforward if you know it's left forward. Clark, is that good? Questions on that? Like the algebraic stuff there? Alright, let's get the graph. More interesting, I think. So, I want to just kind of talk through what's happening in the graph, and then we'll answer the questions. I've got this particle, and this is the velocity. So up here, my velocity is positive. So I'm moving forward at like 2 miles per hour or whatever. Here I'm moving forward at 1 mile per hour. Here I'm stopped. So in this time, is the velocity positive or negative? Positive, why? We're above the axis. We are moving forwards here. When we're below the axis, our velocity is negative, because negative numbers live below the axis. We are going backwards there, and then forward there. So when is it moving to the right? So the right is positive, so it's forward. So you're going to say from 0 to 1, like that. And then mad. I put a bracket around the 0 because when x equals 0, the velocity is positive. I want to include 0 because the velocity is positive. I'm not including 1 because what's the velocity of 1? 0. And that's not a positive number, so I'm not going to include it. It's also moving to the right from, what the frick? Yeah, well, 4.7, well, I don't know what that's supposed to be. To 7, and whatever number that is. I wouldn't include that point or that point because we're not positive there. We're actually. And then moving left, but I got to justify it because velocity is greater than 0. What is moving left is just the other one. So we're down below the axis, negative velocity, which is moving backwards. So it's from 1 to 4 point frickin' whatever. But that's so annoying. And justify it, well, that means because velocity is less than 0. Okay, now we get to acceleration. They're asking where is the acceleration, positive or negative. So think about how do you get from velocity to acceleration. This is not just what do you do to go down? So this is the velocity. I want to get to acceleration, so I have to take the derivative of take the derivative of this graph, it just means I want to look at the slope of this graph. So right here, is the slope positive or negative? Negative. So therefore, is the derivative positive? Negative. So therefore, is the acceleration positive? It's going to be negative. So the slope of velocity is acceleration because the derivative of velocity is acceleration. So the acceleration is negative between 0 and 2. And then also between 6 and 7. I included the 0 because there is a negative slope there. I didn't include the 2, the 6, or the 7 because those are like 4. Or they're at 0. Oh, that's just positive. Alright, so negative. Wait a minute. What did I do wrong? What am I doing? The first one is negative. I asked you what's negative. We talked through what's negative, and then I wrote that. Okay, positive. So now I want to think about I'm still acceleration, which is still the derivative of that, which is still the slope of that. So where is the slope of that? Positive between 2 and 6. And then where is the acceleration? 0 is saying where is the slope of that graph? 0, which is saying like no, it's not at 1. Where's the slope of that graph? It's not even at 2 and 6 because that is a corner. You'd be looking for like that or that. But remember, we can't take the derivative at a corner because the slope's different from each side. So when is it 0? This one's never. It's an immediate change, which somehow happens without time passing at all, which is like mind. Okay, when does the particle have the greatest speed? Speed is the absolute value of velocity. So I'm just going to sketch the graph, and that means anything below the axis flips up. The speed graph looks like this. That's the speed graph. Then just take everything that's not positive and make it positive. So the highest speed happens when t equals 0. We're at 2. And at t equals 2. Because the speed is 2. It's just like the biggest line. Right? Okay, when is the particle speeding up? Speeding up means the velocity and acceleration are the same. So, let's just start with like, where's the velocity positive, and then we'll see where the acceleration matches. So the velocity is positive here, right? Because we're above the axis. But the acceleration is the slope. So the acceleration is negative. So in that area between 0 and 1, we are slowing down because the sides are opposite. And I'll justify it all in here. If I look at the next section of the graph, so here, my velocity is now negative because we're below the axis, and my acceleration is negative as well because the slope is negative. So I've got negative y values and a negative slope. So because they're the same sign, I'm going to be speeding up. 1 and 2. See if I can color code this whole thing. My next section would be here. So my velocity is negative. Why is my velocity negative here? Because I'm below the axis. And my acceleration is positive. Why is that? Because the slope is positive. So when they're different, that is slowing down. So from 2 to 4 points. Screw you. It makes me so mad. But why? But you don't know.
You don't know, but you don't know that it's 4.71.
I know. That's why I'm angry.
Make it simpler
next section. Right there, my velocity is positive because we're above the axis, and my acceleration is positive because we got a positive slope, so we are speeding up between 4 point whatever and 6. I got one left in the corner. I can't see it right. Let's try. So my last section is this here. So my velocity would be positive because we're above the axis, and my acceleration is negative because the slope is negative. So that would be slowing down because those are different things. And then I would justify by saying like B of t and A of t have the same sign. And then on the bottom one I would just write B of t and A of t don't have the same sign. Is it okay if I don't write that out? Question I can answer, especially on the graph. I started to feel like the more we went, people started to click a little bit. I think I can answer this. Is that the last thing? Okay, so you. I should have asked this at the beginning. I was going to go over the lessons either way. Give me thumbs on how you understood it. I don't know what you would answer. Try it. Give me thumbs now. Go ahead, Edward. Are getting paid. Your currency is free. That's true.
Breaking news. Breaking news. I was thinking about that.
Let's be calculusing, please. How do you guys think?
She not teach you guys that.
Oh,
He like taught.
yeah, he could have taught it so much more simpler. Like power rule, I could barely understand power rule.
It's so easy.
Yeah, it is.
He like not taught you.
If I taught physics, it's the same thing.
Yeah.
NASDAQ like use your notes.
Yeah, no.
I love it so much.
He made a worksheet or whatever.
Yeah, he used to come out to school